Hey, what's up, everyone? Welcome back to my channel. And today we're going to be continuing on to the topic which we left on in our last video. So we discussed about numbers and what different types of numbers we have, and we stopped at rational numbers. And so we can only continue on about understanding what rational numbers are. So rational numbers are, in simple words, they are like of the form P by Q. Q should not be equal to 0. This is very strictly done. And in simple words, P, Q should be integers. So this should be integers. And P, Q should not have common factors. This is a basic definition of rational numbers. Let's understand why Q should not be equal to 0 first. So if I take an example of pi upon 0, this kind of fraction is not defined. Anything, any number upon 0 is not defined because this gives us infinity. So this is obviously not possible. That's why Q should not be equal to 0. P and Q should be integers. Integers like integers run from minus infinity to plus infinity. And P and Q should not have common factors. What does that mean basically? So I can 2 upon 20, 1 upon 10, 4 upon 40. These all are equivalent to the simplest form is 1 by 10. In other words, if I take 2 upon 4, 8 upon 16, this all turns out to be the simplest form. Okay, so this is what a basic definition of rational number is. I hope you got understand that. You understand what the basic definition of rational numbers is. Rational numbers. Let's move on. Let's go to a very new section, which is PFAM, which is think for a moment. So we'll just use our brain and just see what these statements are. Because when we think, our brain, we get more smart. So over here we have the very first question: is every whole number a natural number? And whenever we have this every kind of questions, just have to give one negotiation, or in other words, one example where the statement is not true. So every whole number is a natural number means I can, but the whole number consists of also has 0, but that 0 does not belong to natural number. So basically, this statement is this misquotes. You cannot say that every whole number is a natural number. Every integer is a rational number. The statement itself says that it should be in a form of p by q, and p and q should be integers, meaning I can write every integer in a form of rational number. For example, if there's uncertainty over there, I can say I can write 4, 5, 6 as a rational number because I can write 4 upon 1, 5 upon 1, and 6 upon 1. Or maybe like 12 upon 2 is also considered as 6. 8 upon 2 is considered 4. So I can write all these, all I can find, I have no integer which cannot represent as a rational number. So this is true. Let's move on to the next. Is every rational number an integer? Over here, we have to, it's a very skeptical statement over here, right? So let's say 4 by 5, which is a rational number. Can I represent it in an integer form? I cannot. Integer runs from minus infinity to 0 and then plus infinity. And it does not include fractions, which means I cannot represent every rational numbers as integers. I can represent 4, 5, 6, 7 on as an integer, but I have come across one such examples where this statement is not true. Last and the very trickiest question is 0 a rational number? Now again, 0 basically is integer, if I'm not wrong. And I have proved over here that every integer is a rational number. What does that mean? Which means 0 is also a rational number. Let's take an example. I can write, q should not be 0, right? But I can write p equal to 0 and denominator be an integer, which is 3. 0 upon 4, 0 upon 121. So I can write all such examples which are all equivalent to 0. So I can write 0 as a rational number. I hope this is fine. Very interesting facts about. Okay, then now we move on to a very important statement, which is there are infinitely many rational numbers between any two given rational numbers. Now let's understand why this statement is true. I'm going to be using an example over here, which is find 5 rational numbers between 2 and 3. Okay, so for solving this sum, I'm going to be using again my number line. Now 2 is over here, 3 is over here, and I have to find numbers between them. So the easiest way is to use the midpoint concept, which means if I have 2 extreme points, I can find the midpoint of them. So over here I have 2, I have 3. What I'll do, I just add them and divide by 2. This turns out to be 2.5. This is 5. This is over here. So 2.5 is over here. So one of those rational numbers is 2.5. Now what I'll do, I'll take 2.5 and 2 as my other numbers, and I'll repeat this again. So I'm going to get a number over here. It's 4.5 to something about 2.25. This is going to be a second rational number. I can go on and on and on, and you can easily find 4 rational numbers. So it won't stop at 5. I can continue on and on and on till infinity. That is why the statement that there are infinitely many rational numbers within any two generations. I hope it's clear. Okay. Now the thing about this method, now you might be required to solve certain questions in your book for class 9 to class 10 for ICSE or CBSE board. So let's say this is very cumbersome process, right? For 5 rational numbers, it's fine. But if I have to find 12, 13, 14, then this becomes a very hectic or very tired process to do. And mathematics is all about doing the long thing in a very short time. So let's take, so you have to understand this. So find 5 rational numbers. This is our hint. So whatever the desired number of rational numbers that you find, just add +1 to it. So over here it's 5, just add 1, which means I'm going to get a 6. This is a magic number. Now how we're going to work around with this magic number is we're going to use 2, we'll multiply 6 and divide 6. This is again, I can add 2, this, and for 3 it's multiply 6 and divide by 6. This becomes 1, so it doesn't make a lot of change to this equation. But what will happen over here is this becomes 2 6 12, 12 upon 6, and this becomes 3 6 18, 18 upon 6. So I have 12 upon 6, and then I can see that there are possibilities to find other 5 numbers over here. And then I have 18 upon 6. So I can increment 1 over here. So it will be 13 upon 6. This is 14 upon 6, 15 upon 6, 16 upon 6, and then 17 upon 6. So as you can see, I have found out the other 5 rational numbers very, very easily. This is nothing but again 2 over as I said, and this is 13 by 6 because 13 is a prime number. I cannot consider anything here. The 2 common in the both numbers, so this is 7 by 3. There is 3 common in both, so this goes 5 by 2. There is 2 common again over here. This is 8 by 3, and 17 is a prime number, so it remains as it is. And then last is 3. So I found out these three rational numbers equal to 20. I can easily plot them over here. I hope you understand this. So this was brief understanding of rational numbers. So the important thing over here is there are infinitely many rational numbers with any two given rational numbers. That is what we should remember. Let's move on. Okay, so now before ending this video, I have a fun fact that this fun fact will lead us to a new topic over next video. So the ancient Greek mathematician Pythagoras believed that all the numbers were rationals. So initially, Pythagoras thought that there were only rational numbers, but one of his students, Hipparchus, proved it is speculated that he used geometry. So he used geometry and he showed that there are certain numbers which you cannot write in terms of fraction. So he found out that square root of 2 cannot be represented as a fraction. So if certain thing is not represented as fraction, it contradicts the statement of rational numbers. So what they found out that such numbers should be termed as irrational numbers. Now, no doubt, Hipparchus did a wonderful job, but the followers of Pythagoras were not at all happy, and they could not accept the existence of irrational numbers. And it is said that the Hipparchus was drowned at sea as a punishment from the god. So, yeah, this is a very fun fact. So, that's all for this video. I hope you have understand what rational numbers are. And the next chapter, in the next video, hopefully, we're going to start out with irrational numbers, and we're going to dig down and understand what are irrational numbers and why they are called irrational numbers. Thank you so much for watching this video again. Stay tuned for the other video. Thank you so much.